the correlation between RAM and disk is one of the things that are so simple to understand, but so hard to grasp.
Welcome to Fork Around and Find Out, the podcast about building, running, and maintaining software and systems. Let's be honest, not all podcasts are created equal. Some podcasts are just boring, especially tech podcasts where the hosts have no insights or credibility around the software they're talking about. But let me tell you about software-defined talk. In this show, Brandon, Matt, and Kote talk about DevOps, cloud, and Kubernetes, things that you're interested in because you're listening to this show, but they take a different spin on those topics. In most cases, they're going to talk a little bit about the tech and a lot about how it affects a business or a community or the broader industry around a technology. So you're not just hearing about it from a developer who used a tool once in production. Software-defined talk gives you more insights that are probably adjacent to what you're used to. I'm a longtime listener of the show, and one of my favorite things is the recommendations. Every week they give you something that they recommend, whether they learned something, they read something, or anything about technology or not technology that I've always found fascinating. Even when I don't have time to listen to the show every week, I will still often go to the website just to see what they recommended. So check it out at softwaredefinedtalk.com. Welcome back to Fork Around and Find Out. I am Justin Garrison, and with me as always is Autumn Nash. Today on the show, we are going to stream process this Kafka queue with Elad Eldor, the author of Kafka Troubleshooting in Production and a data ops engineer at Unity. Welcome to the show, Elad.
Thank you for having me.
We were just going into details before recording this about not only how cool, like, your name sounds like a great character in any sort of like
the coolest
fantasy book. Yeah, yes. It's just fantastic. But then like the fact that you're working with Kafka and like data streams also sounds a little magical sometimes. Like this sounds like a spell that you're casting.
To do cool things to all the data and like stream it. Like I could just see like a book cover with like a wizard like streaming data. Like it'd be so cool.
The book cover is, it looks like a tree. So yeah, it streams somewhere into the earth or something like that.
Love it. Let's jump straight into, tell me about the book. The title of the book is Kafka Troubleshooting in Production, Stabilizing Kafka Clusters in Cloud and On-Premises. And the first question I have is, why is cloud and on-premises different?
That's a big question. So
we got a lot of time.
Just coming out of the gate hot. Like
yeah, to answer this, I'll start with the interesting story of how I became like working with Kafka, because the intention of the book is for people like me, people who had no experience with Kafka or Linux, by the way, to get into troubleshooting. I started like at 2016 working with Spark and Kafka. I was a backend developer working at an on-prem company that sells all the machines, not only the software, to clients in the defense industry. Clients, and all things worked, but the major issues were with Kafka. So after some time, I had enough with going to DevOps, trying to get some help. They also didn't know Kafka very well. So I had to dig into Kafka, and turned out that this was like, I had some 10 years of experience with open sources, and nothing was as tough as Kafka, and nothing was so pivotal as Kafka. It's in the middle of everything. A small problem just spans over the whole pipeline. So then I started getting into troubles like one by one, understanding how to solve it, learning Linux on the way. I didn't only try to understand issues in Kafka. It was also clusters I became SRE in charge of Presto, Neutrino clusters, and HDFS and Spark, like on-prem, no one, free distributions of Ambari that bundled together Kafka and HDFS and Spark and whatever, and no support from anyone, only logs. And customers are abroad. They had to go to India and Uzbekistan, all sorts of weird places, which I really liked, but they're still weird. trying to like going over logs, the Persian Gulf, etc. So, and I took Brendan's book to every place, and it just was like all the solutions were in his book, and he described this in such a way that I fell in love with Linux tuning and understanding bottlenecks. And again, it was on-prem. So getting back to your questions, the question in on-prem, you don't have any assistance of anyone, but you can look at over all the logs. And one of the problems that don't occur in a cloud is that the hardware just fails. You have RAM DIMMs that get defected. Disks start to burn out slowly or fast, and even one disk in one cluster can just destroy the whole cluster. That's like the con. The pros are that you can create your own cluster, whatever RAM you want, however storage you want, whichever disk type you want, and like build your own little cloud. But so it was a mixture both of like having access to everything, but seeing failures that you don't see in the cloud, but having the freedom to design your own cluster, or at least try to design your own cluster, because you need really to estimate. I know that you moved on from EKS Anywhere in AWS to a company that works with EKS clusters on-prem. The issue is that you like designing a cluster that will fit into the budget and not cost you a lot of money is something that is very hard to convince and very hard also to estimate, because traffic today is X, tomorrow it's 2X or half X. So these are challenges that I didn't face in the cloud. It's the best school for becoming an SRE in every open source. You have full accessibility to all the tools of Linux. Like you can see all the metrics in the disk, and like create your own monitoring. What AWS engineers do in their data centers, you just do yourself.
Which is good and bad, right? I mean, it's like that's all the responsibility of now I need a reliable log engine, right? Like those sorts of things are just like, oh, this sucks, but also a lot of log aggregators are better than CloudWatch logs, right? CloudWatch is pretty terrible when you look at anything you can run yourself, but there's more responsibility to run something yourself.
I also think that it's like, do you have the time and the team and the ability to run it yourself? Like, I think when you can sit there and build something and run it yourself, it gives you that like ability to really understand it. So you end up in a better situation, but you have to have the time to spend and the ability to really run it yourself and do all that. You know,
well, that's exactly how this conversation started, right? Like no one knew how Kafka worked. And so Elad's like, I'm jumping in and I'm going to invest the time to accidentally make this my career.
Exactly. So when I moved to the cloud, I worked at a company that had many sites, so many different deployments, not only of Kafka, of consumers and producers. So I saw a vast amount of, like compared to like an ordinary SRE, because there were many sites, I saw so many cases of producer errors, consumer errors, Kafka errors, hardware errors, like whatever. I built like I designed clusters with a mixture of different disk types, different DIMMs within the same machine. Like I learned how to combine DIMMs in the two different types of DIMMs at different sizes, like how you sort it in the JBOD of the DIMMs was really crazy. So after like 3 years,
is that for performance? You're splitting up?
No, that's part of the issue is on-prem is that you have a cluster and it's now at the customer site. It is DC. Now you lack storage. So what do you do when you lack storage and the JBOD, you have a JBOD of disks and you have 24 disks of, let's say, 4 terabyte. So are you going to throw away all the disks because you need 16 terabyte disks or 32 or whatever? The customer will get mad that you throw away the disk that he paid for, although it makes sense, but you cannot really do it. So you can say to him, okay, I'll throw half of the disk that you bought and I'll put in 16 terabyte disk, but then how do you make a JBOD work with 4 terabyte disks and 16 terabytes? So there is a way of doing that like you do 4 terabytes, 60 and 40, 4 or 8 terabyte. Same goes with DIMMs. You have 24 a box of 24 DIMMs of 16 gigabyte RAM, but you need triple that size. You are not going to throw away all of it because the customer will not get it, will not accept it. I learned that there are several types of customers, by the way. Customers in I don't want to mention geographical places, but some customers they get really attached to their DIMMs and disks, and they like a lot of machines and a lot of disk and whatever. So sometimes you need to mix.
And Kafka's, it's one of those pieces of software that seems to work its way in a lot of places, in a lot of industries. It's not because it's a generic sort of stream processor and pub sub. People are just like, I'm just going to use it for whatever I want in this case, right? And there are other tools that kind of do that. Some of the older ones like Zookeeper and whatnot are known to be a little worse to operate and try to use or have less features. What is the most common scenario that you're like, someone uses Kafka for this purpose? And what's a use case where you see someone that like puts Kafka in place and they shouldn't have used Kafka?
I think that I don't have any example for why not using Kafka if you want to write something that many consumers will read. For example, or many producers, many consumers like end-to-end, one-to-end, end-to-one, like whatever. I can't think of any example why not using it.
Kafka is a Swiss Army knife of like streaming data because it's open source. So many people have made their own version of Kafka, but it's really just Kafka, which means it's like Kubernetes. Like you can go from one place to another and people know that if they do know it, right? Like if they know some sort of streaming, it's going to be that. So then people just use different versions of it because it's the most common. Like, you know, people use Kubernetes because they have the, like, there's the learning, there's the different projects that are built on it, the ecosystem of the community, you know what I mean? And Kafka is like the ecosystem of like streaming because everybody uses it everywhere. So if you're going to do the struggle, you might as well do the one that has the most ecosystem to support whatever you're about to, like the ride you're about to go on. And for a long time, streaming was new everywhere. Like streaming that much data, we were all trying to figure it out at the same time.
Yeah, before that, I used all sorts of streaming open source. The last one before Kafka was HornetQ, but before that, there was some other open sources, and there always was an open source that replaced the last one. Since Kafka became like a synonym for moving data from X to Y, and it works very well with small traffic, by the way, really, really well. And that's one of the problems with it, because once you go up the traffic, at some point, you get into problems that are much harder than what you anticipated, but then you're already locked in. And Kafka makes it really tough to, Confluent exists for a reason, let's say, or Ivan or like whatever, but like it's really hard to understand what happens.
Can you describe that more? Like at what point do I say, I only had a little bit of traffic and now I have a lot of traffic and I need to re-architect or change how I use it?
No matter how you architect it, I noticed that I started at rates of 10K, 5K. At 5K, 10K, I didn't see any environment that had issues. But starting from 100K, you start to suffer from consumer lags or producer that get that their buffer are getting full. And data skew really becomes an issue, and skewing the storage of disks, mainly, by the way, if you work with several disks per broker. So you have a skew per disks, you have skew per the storage in the brokers. I mean, in the book,
Is that skew for delivery time, or is that like just how long it takes from the producer to get to the consumer?
not latency. I'm not meaning that. I mean like traffic skew, like number of messages per partition, per topic, and the skew in the number of leaders. What?
Partitions are so, it's like a wild ride. Like learning how to do that properly.
Partitioning correctly. So partitioning by, do you want round robin so you have an equal amount of data, or do you want to have a better aggregation ratio? So in that case, this is really bad to go round robin. And what happens when you have the same number of partitions per broker, but you have a skew in the leaders? The main issue when I started was leaders that became non-leaders, like just leaders that are lost. And you like
Is that from a network partition that they forgot their leaders, or do they get?
no, just a leader partition. Now it is not a leader
It's
partition,
just
and
distributed systems and just trying to do that with data. Like what you're saying is so true because I think when people want you to architect a system, they're just like do magical things and then account for the scale, but you can't, right? Because what some qualities that you really want at a smaller scale that makes it more efficient, you can't do that at a bigger scale. Like it just at some point you're going to have to re-architect and rethink of things, and it's going like leaders are going to die or switch, and just you have to do that. You know what I mean? Like there's no way to skip that.
it's not even re-architecting because you can have topics of at millions per sec at produce rate, and you can have multiple consumers on that topic and not have leaders getting lost, while you can have a topic at 1/10 of the size and get leaders get lost. It depends like on how you monitor your Kafka and what you do in the producer side and the consumer side. You can have everything right on the Kafka infrastructure, but having some amount of consumers can cripple down the broker and the cluster. You can have 20 brokers and one faulty disk can cripple the whole cluster. It's so vulnerable, Kafka, compared to I work at high scale with Druid and Trino and Spark, and Kafka is just a different animal. It is so important and pivotal and vulnerable at the same time, both on-prem and on the cloud.
What do you think was your hardest kind of mountain that you had to climb learning? Was the cloud or on-prem the hardest for you?
The cloud, because when like the on-prem was because it was hard because I didn't know system performance, but while reading Brandon's book and the troubleshooting stuff along the way, it's small traffic. Then once I moved to the cloud and it became topics of a million per second when I started working at Iron Source, then before it got merged with Unity, the problems were different. Like when you go 10x in the traffic, you see problems that you just don't see at a small traffic. And this was tough because I worked on-prem first, yes, for 4 years, and then moved to the cloud. At huge clusters, you have like 100 of monitoring dashboards. And when you have some problem, you need to just correlate a subset of this 100. But I spent tens of hours on understanding each problem. There were more interesting problems, but I think it was tougher. Moving to the cloud was tougher just because of so many monitoring and so much traffic compared to on-prem.
Do you think the abstraction made it harder, or was it just the fact that of the monitoring and the more traffic?
I think the more traffic, yeah, the more traffic you have, it's not just traffic, not just number of messages. It's more producers, more consumers, more combinations of features like compacted topics, along with many consumers and many producers, trying to have a small cluster to sustain high traffic. Because on-prem, when you sell a customer a cluster, big data cluster, analytics cluster, so usually like companies sell the amount of machines for Kafka. There are much more machines for Kafka than for other data tools, because like managers are really afraid of problems in Kafka when they sell a system as a whole. So usually you have a lot of brokers compared to the amount of traffic. But on the cloud, you can shrink the cluster. So you have usually you have much less say, compute power in the cloud to sustain much more traffic. I think it makes the problem harder, but throwing money on the problem also doesn't solve the problem.
We talk about money solves all technical
I was
problems.
going to say, can you say that one more time so they can hear you?
One of I repeat system performance again. One of the things that Brendan showed is that you can save a lot of money when you understand bottlenecks, not only in Kafka, but understanding storage, where your bottleneck is, storage RAM or disk IOPS or throughput, is something that once you understand it and you can communicate it to the stakeholders, then it becomes much easier to reduce cost, which is, by the way, a problem in on-prem, because you need to guess what the load will be. And it's hard to guess it. While in the cloud, it's easier.
Your book is focused on troubleshooting. Are there specific tools you're using to troubleshoot Kafka? Like everything you've described sounds like mostly traditional Linux troubleshooting, right? You're looking for disk pressure, you're looking for RAM usage. What does Kafka troubleshooting look like? How is it different than like standard Linux performance tuning?
It is very similar to standard Linux tuning or tools. Like the first tool I used was IOStat, like disk utilization. The util column at IOStat, I think it's the most important column in every IO based database. But then I discovered all the other columns, which are also really great in IOStat. So IOStat is my first tool, and then you have VMstat to understand the CPU the CPU usage, but then you need to understand like what's the difference in Kafka. It's very important to distinguish between the various types of CPU. Like third of my book is just summary of a very short and summary of what Brendan wrote about storage, RAM, and CPU. So in CPU you have system time, IO wait, user time, and interrupts or context switches. Per each of them, I can give an example of how Kafka can cripple down if some type of that CPU metric goes up even a bit. And on the RAM, which is the most interesting part, it took me I think 2 years to understand it. The way that Kafka uses RAM made me understand how RAM works in Linux and mainly the page cache. So the correlation between RAM and disk is one of the things that are so simple to understand but so hard to grasp, and it causes so many production issues, mainly for clusters that use Kafka as a database that save several days for replay and then start to replay data, and then producer get stuck, and that's mainly because of RAM. Like Kafka just uses the page cache mechanism that you read what you write. But if you are late in reading, then you start trashing the RAM and hurting consumers and producers. And by the way, in on-prem, if you are late in reading and you start reading from the disk, then the disks get hammered because of that, and then they just fail. So consumer lag in on-prem can cause failure of disks. And this correlation is just like so. So Brandon wrote a tool called CacheStat to show the hit and miss rate. So like these three tools, like IOStat, VMstat/top, and CacheStat, they can solve big part of Kafka production issues, along with using Grafana, because there are several other metrics that are not Linux based.
From Kafka itself, yeah.
Yeah, and there are several metrics like network processing threads, for example, that you can say, okay, if it's high, someone is suffering, consumers or producer of the cluster, but someone is not feeling good.
It's like you're reminding me so much on how Linux, the operating system, is a lot like a distributed system. Like everything you just described is basically a series of queues that Linux is managing. And it's just like any distributed system where like, oh, I have my cache over there. I got my, my Redis instance, my web server, whatever, like something processing, like that's all happening within the OS as well, managing all of the hardware, RAM, CPU, back pressure, disk pressure, all that stuff is basically what we do on distributed systems too. But how does that then relate to Kafka is also a distributed system, right? Like you're doing all of those low level things on tens or 20s or, hundreds of machines for like a large Kafka cluster. How do you then correlate those things between? Is that all just, you have to have some external Grafana dashboard that's pulling over higher level metrics and then you dig in to find the hotspots and problems?
Yeah, so Grafana really, without it in a cluster with millions per sec, you can't diagnose anything. If you have such a cluster, my recommendation is setting Grafana with metrics of CPU and have a distinction of CPU usage per broker over time, of CPU system time, IO wait time, user time, and interrupt and context switch. I will later explain why. And then another dashboard, this is the CPU dashboard, and also load average. Load average is super important, normalized load average, like dividing the amount of currently running tasks that you can get from Vimstat and dividing it by the number of CPU cores after hyperthreading. So that's the CPU part. Then you have the storage part where you can see the disk, the IOPS, the read IOPS and write IOPS. Make sure that you don't have a lot of, if you have spikes of read IOPS, then probably you're trashing the page cache. And storage distribution between the brokers, even not per topic, just storage distribution. And then the distribution of partitions, followers and leaders between the brokers. So that's the storage part. On the RAM part, it's really hard to monitor it because it's very difficult to monitor the page cache, whether you trash it or not. And number of messages, of course, per the traffic per in and out per broker, because this can help you to understand whether you have a data skew. And data skew is one. I'm not saying it's the root of all evils, but it's one of the evils in every database, especially Kafka. Like today, for example, I ran into a problem of a broker crashing, and the follower was really late. Like it was 15 minutes late on its offsets, and the consumer got an offset that it already 15 minutes before. And we looked at the possible reasons why it is not in sync replica. But then when you look at the dashboard, you just see a skew on the brokers. But the number of partitions is the same in all of the cluster. So what is the reason for that? And the reason is something that every Kafka owner should have monitoring, not only the number of partitions per broker, but the number of leaders per topic per brokers. Because if you create a cluster and then just migrate all your topics, not related if they're big or small, what Kafka will do, and that's again what makes Kafka so hard to maintain. Kafka will not say, okay, I'll just distribute the big topic, then this medium topic, then the small topic. It will just distribute it so it will have the same number of partitions per broker, regardless of their size. And then all sorts of problems can occur. Then you look at the cluster and say, okay, I have the same number of partitions per topic, I am distributed, but the number of messages is not distributed, the storage is not distributed well, and that's because you have a broker with a lot of leaders. It gets really hard for it to replicate its followers.
When I last was doing large things in the cloud, the thing that I often ran into was just API limits, right? Like my account can't do certain things. I'll have API limits for like it, and some of them are arbitrary, like disk IO, right? Like the type of disk I have and the size of the disk depends on how many times I can write to it, versus owning my hardware and having something on-prem where it's like, hey, whatever that bus speed is what I can use. In cloud systems, I'm often like, I'll throw some money at the problem. I'm going to make this a 1 terabyte disk, even though I only need 200 gigs, just to get more throughput out of the disk. Where do you find those sorts of like hidden infrastructure problems that like creep into this as like, hey, something outside of Kafka is causing a problem? And almost every time it's DNS, right? Like you're like, oh, DNS is down. I have no network. I can't talk to the broker or something. But like in general, have you seen like patterns there where someone says, oh, I don't know what's going on, but Kafka's not healthy, and it's something outside of the cluster that was affecting it?
I haven't seen APIs issues in Kafka. I saw it in some other cloud services, but not in Kafka. And also, throwing money on the problem when talking about Kafka never helped. By the way, it helps at some other clusters.
Unless you're getting like a managed service, which still doesn't always help, because then you have to figure out the problems with that. You know what I mean? Like you don't know what's underneath and what's going on. So
I don't know what you mean because I never worked with managed Kafka, but I guess that like I am working with other managed services, and there are always cons and pros for managed versus open source. But this happens also not only in Kafka. It's more of a question, I think, of cost reduction, of how to spend money on clusters when you don't need to. And the main issue that causes spending money in Kafka is storage. Like buying expensive machines when I was designing on-prem clusters, I was exposed to the prices of CPU and RAM DIMMs and disks. So CPU cost the most, like because the machine cost the most. But adding CPU after you buy the machine, having more CPUs costs less than having more DIMMs. DIMMs cost the most, but disks cost the less. But what's interesting is that mostly the bottleneck is storage, because customers of the cluster that just need to store more storage and they have more traffic. And then you need to scale out by buying CPU and RAM that you don't need in order to support storage that you do need. And this happens not only with Kafka, by the way, and then your cluster starts to scale out and you just buy more and more storage. And in AWS, for example, you cannot build your own, like decide how much storage you want. In GCP, you have more freedom in doing so. So that's the main case where I see that due to storage limits, you need to pay a lot of money on CPU and RAM that you don't need, which are the most expensive part of the cluster. But another source of spending money is, of course, networking on the cloud.
You know when you're driving down the freeway and you see one of those billboards that say your ad here? This is basically the audio version of that billboard. This is Justin Still. We are still looking for sponsors for this podcast. We are having a great time learning with everyone in the community about how infrastructure works, how people are adapting to problems, and even looking for solutions that solve some of those problems. We don't do pay-to-play episodes, but we do love to promote people in the ad spots so other people can learn about what you're doing. If you are a sponsor and you're looking to reach this audience of developers and engineers, go to fafo.fm/sponsor and check out our packages. The storage, RAM, CPU, and networking are all intertwined, and scaling one up isn't going to solve the other problem. But like you mentioned, the bottlenecks show up in different ways. Like at different levels of scale, you're going to have RAM bottlenecks versus data bottlenecks, right? And so you have to just kind of balance that over time.
But I think like the distributed systems and then learning like partitioning and databases and then just learning how like throughput and everything is already complicated. And then you add in the networking and all of that. Like there's so many layers of things that you don't necessarily like learn in school. And then you have to put it all together and figure out how to scale it. It's so complex on trying to figure all that out.
And it's also complex that in for example, in Kafka, understanding that sometimes the cost of the network costs more than the cluster itself, which is usually not the
network
problem
traffic.
The network traffic. And
is that for on-prem too, or just in the cloud? Because I feel like
no.
Okay, because I was gonna say like, how many times have you heard the most ridiculous charges for cloud networking for just multiple use cases, and you're just like, I would have never expected that to be where we spent the most money.
I will not comment on that, but
there are plenty of people that I know that the largest portion of their bill for various clusters, especially Kubernetes, Kafka, whatever, it's networking between regions and AZs.
It's like the secret that nobody tells you, you know, like you're just like, and then this will make it cheaper, and this will make it cheaper.
The secret bank for cloud providers, hell
but
yeah.
It's funny though, because like that's never like in a book, you know, like it's like that's how you know when someone's worked with stuff for a long time, because of like that they're gonna call that out the first thing when you're like re-architecting
and
something.
The problem is always every cloud calculator leaves that up to the reader, right? Like, hey, by the way, depending on how much traffic you have, here's our rates, right? And
have you
then
ever seen the post where people are trying to calculate how that works, and sometimes you can't even calculate.
It's impossible. And then also on-prem, because it's a free resource, that would be like trying to calculate how much power you consume. Right? Like your data center consumes so much power. Like, well, I know my data center is capped at this, so I'm not using more than a megawatt or whatever, but like, I can't tell you if I'm using, you know, whatever power I'm actually consuming at any given point. And I feel like that is just like one of those points that cloud providers really leaned into, that like people don't know this metric, so we're going to charge them for it. And we're not going to charge them a lot until they go over.
At some traffic, it can cost like twice than the cost of the cluster, like 3 times. Like the cluster cost becomes irrelevant, and this is something specific to Kafka, the cost of the networking. And if we go into that, so first of all, for our listeners, look at the cost of the networking between your producers and consumers to your Kafka brokers. And you will be amazed how tough it is to calculate it, first of all, as you said. But then once you see the cost, like you will have a new target to focus on, and you will go to rec awareness.
In Kubernetes, we have like AZ steering. Like we can steer traffic to know what the topology of the cluster looks like. And we say, hey, don't cross this border if you don't have to, right? Like it's okay to go across AZ, but I would prefer you to stay within AZ or within the VPC. Does Kafka have something like that? Like some sort of steering for traffic to say like, this broker only should stay in this AZ, or this data should only be part of the, the consumers in this AZ?
Well, there are, of course, parts of Kafka that I don't know. And one of them is I don't have an experience with rec awareness, and I don't have an experience yet with Kafka on Kubernetes. But I do have experience with Kubernetes in other places. And the issue is like having to reduce network cost in Kafka. You need to reduce network traffic, which is very high sometimes. There is a feature from some version in Kafka that reads from followers. But then you need to tackle basic questions of whether your followers are in sync. Because when you don't have rec awareness and you read only from leaders, you're okay because your leaders are already they're synced because they're the leaders. But once that you have rec awareness that you will need to read from followers. But what happens if your followers are not in the ISR list, not in sync replicas? So to reduce cost, networking cost, you need to figure out how to make your application really work and not be lagging, because then your consumers will crash if you move from a leader to follower. So it's tough to reduce cost of networking to implement rec awareness.
And that probably has the biggest trade-off of availability. Best practices, every best practice guide in AWS is like spread your workload across AZs. And as soon as you say, I need leaders in every AZ in my region, you have to replicate some traffic between them. And if you say, oh, I only want this leader to talk to this AZ, it probably only has the data for that AZ or something. And so if that AZ goes down, where does every other consumer get the data that they required there? So it's like this constant trade-off of like, how much can you pay for availability, how real time, and how much data, like, is it okay if you miss some data? Sometimes some systems are, yes, that's okay. Like I missed a log line. Okay, that's all right. Like we call it sampling. It's not the worst thing, right? But yeah, I do think that there's a much bigger concern, especially as people treat Kafka like a critical database. Like it is a critical database in a lot of cases, but not all data is always created equal.
Yeah, log is not like a billing data. It's different. And you had the right point. That I missed before is that when you need to make sure that no leader resides within the same AZ as its follower. So you might even pay more because of you incur more replication due to that course availability issues. Yeah, it's more DevOps work also.
It's just system syncing, right? Like it's like, how do I design a system that meets a price point, but also meets an availability SLA, even if the SLA isn't defined, right? Like people constantly are like, oh, I have to have 5 nines. I'm like, well, you don't, because you don't have infinite budget. And so figure out what your budget is and then figure out how much availability you can have.
But that's the thing, like some things you can kind of be flexible with, but data is one of our most important commodities, and it's usually one of the most important parts of an application. So you can't lose data. You've got to always have a backup. You've always got to have a plan. So it's like, it's so hard because you want to be efficient and you want to be cost efficient, but you also cannot lose that data, So it's like really weighing those costs.
But if you manage to reduce the networking cost, then you can save more data on the brokers. But then if you save more data, it gives you the liberty to replay the data, and then you trash the page cache, and then your consumers will lag or your producers will fail to write. If you manage to save some money in Kafka, my recommendation is don't exploit it even further. Don't treat Kafka, treating Kafka as a database is problematic in terms of cost. And also reducing networking costs. is also problematic because you need to remember that then you need to make replication really work. And it's tough to make replication work because if you have a skew and your replication is not so good, usually like I saw sites that they had under replication in almost all of their leaders, but they weren't affected because it's on-prem. No one cares about the networking cost. But once you're on the cloud and you care about it, so if you want to implement track awareness, check your ISR list and make sure that your application is really correct, and not that you are lagging like 15 minutes or an hour behind your leaders, because you're going to read from followers and you want to make sure that consumers don't fail because they are lagging.
You've been doing this now for almost 10 years. Do you have a tip for someone that was like today, 2025, like I want to get started in Kafka. I want to learn what Kafka's like, how I should use it, how I should architect it, how I should troubleshoot it. Where would you start today?
There is a great book called The Definitive Guide to Kafka, written by someone I think from LinkedIn and two others, one from Confluent also. That was my first Kafka book. I like reading books, but I know that today's generation don't like to read books. But it's a great book for understanding the APIs, not so much for troubleshooting, but understanding like how to work with Kafka. It's a great book. It's written by some of the people that wrote, I think, or developed Kafka. The other thing is getting in touch with the DevOps in your company and sitting with him to understand like what's Linux is about and which tools, like running IOStat on your Kafka and just looking at the logs. Understanding, for example, a typical mistake is looking at IOStat, looking at disk utilization and seeing like 100% disk utilization and saying, oh, that's very bad. I'm 100% disk utilization. But then if you look for an hour, you see that Kafka works in bursts, like a few seconds every minute. It's 100% utilization. So through the logs, through the tools of TOP, VMstat, IOStat, you can learn how Kafka behaves. Deploy your own Grafana with CPU storage and data skew metrics. Start to monitor, like develop monitoring scripts. For example, a simple one but very effective monitoring is taking a topic, going over its partitions, and calculating the traffic into these partitions and making a graph just to see how the skew behaves, how the data distribution behaves. Monitor the number of consumers you have per topic. Monitor the number of leaders per topic per broker. For me, at least, I learn visually and by looking at logs. I can stare at logs for hours and learn like that. So you need to like.
I like how you break it down. I mean, like Kafka is a complicated distributed system, and your first point is like go to one of the Kafka leaders and look at the disk, right? Like just start there, like start understanding little bits at a time and then painting a bigger picture as you go and saying, okay, I understand what this disk is doing, but I don't know why it might affect something downstream. It doesn't matter if you don't understand the whole picture yet. You have to understand little bits and pieces of it as you go.
I learned Linux partly by Greg's book, but it wouldn't help me if I wouldn't look at logs and just stare at the logs running. To understand the behavior, it's like a patient, okay? It's like a human being, Kafka. In order to diagnose it, you need just to look how it lives. I'll give an example that shows it. There was an on-prem cluster that just producer failed to write to it, consumers failed to read from it. And that cluster had 3 brokers and 4 disks per broker. And it was configured in RAID 10. So 2 disks are 1 disk. So eventually it had like 6 disks. If one disk fails, the other one fails as well. So I looked at the IOStat of some of the disks there in the past. So I knew it's a very small cluster. And the client refused to scale out the cluster because it meant that it needs to add 2 more brokers and 4 more disks. And there was a client that didn't want to spend money. So I had the feeling that HDD disk will fail at some point. And then I got the call saying producer consumers fail. And I knew immediately by looking at the IOStat in the past that one disk failed and the other one just joined it. And they told me, no, the IOStat doesn't show anything. So I told them, go to the data center, look at the light bulb on that disk. is it in another color? And then they went into the freezing room of the data center and told me, yeah. So from looking at the logs, in the past I knew that the disk just failed. It is really beneficial to just look at running rows of VMstat and IOStat and preparing your own monitoring. This was on-prem, by the way. It took a month to figure it out, but sometimes disks just, when you look at the average usage, like this is an example of why looking at IOStat is so beneficial. So when you look at an average usage of disk, then you will see the same throughput, read and write throughput, if you look at the average. But at systems that behave in spikes, well, like Kafka, looking at the average is dangerous. And we had some problem with some cluster, and turns out that one disk just didn't handle burst well. So it took it like 3 or 4 times more time to handle a burst compared to the other disks. And you can understand it only by looking at the log and seeing that it is 100% disk utilization, much more time than the other brokers. So it's not even resting. And turns out it was a problem in the disk itself, in that AZ, only for Kafka clusters, by the way. So just look at the logs and prepare your own monitoring. That's the best way to learn Kafka from the inside.
I love you knew what was going to fail. And then as soon as it failed, you're just like the biggest "I told you so" moment, right? You're just like, oh, you know what? Like, I don't even need to look at the dashboard right now. Just go to the data center and look at the lights on that and just tell me, is one of those red or not? But also, like, I remember, I don't know how many times I've configured RAID in my career. And there's always that moment where like, oh, part of that disk is going to fail for whatever reason, or it's either going to fail or get corrupted. And the other drive is just going to replicate. It's like, yeah, this is how you configured me. You wanted me to follow whatever that other disk is doing. And immediately in my head, like I heard my parents saying, like, if all your friends jumped off a bridge, would you do it too? And like in a RAID disk, like, yep, let's go. Like we're just
That's so real though. Like sometimes like you just like, it's like being a mom and then being like an engineer or like a product manager. You're like, it's like just different kids that you're trying to
it's just that constant behavior of like, yeah, this is how you configured me. So yes, this is what I'm going to do. One of my first sysadmin jobs, we had to do knock checks and go look at hard drive lights and like see if hard drives were failed. And like, cause we didn't have monitoring, like we literally had zero monitoring, like a dashboard to tell me, even though the hardware offered it, we instead had people monitoring. And so every day someone would go to each data center, each knock, and we'd go look at the rack. And I'm red-green colorblind. And I kept telling them over and over again, like, I physically cannot do this job, or at least this part of the job. And so I would always have to take pictures of the rack of lights and like send them to someone else. And I'm like, hey, do you see any red lights? Because I didn't even know that I couldn't see the colors, because they was like, oh yeah, they're always green to me. Until one day someone came in after me and they're like, Justin, why didn't you tell us that light was red? I'm like, I don't know that it's red. Like it looks green to me. And yeah, it's just sometimes we definitely need systems in place and not put people to
when you said that they had system options and they picked people, like a part of me just like, like why would you do that?
I mean, this was 2000. Oh, what was this? 9 or 10? Maybe 11. But yeah, it was just the environment we were in. It was not set up to do this sort of. We had no priority to do that, let's say. And there was priority to send people to rooms and look at lights. Sometimes solving the problem with people is easier for a company, right? It justifies the headcount. It justifies the time, all of those things. And sometimes getting too sophisticated can cause problems at a business level.
Try working for a managed database and then going to like meetings with a bunch of like DBAs and like engineers and data engineers that do not want you to like do well in that meeting.
Regarding your point, like monitoring the OS is something that like today with the cloud and everything, and most developers or ops, they don't have experience with on-prem. So they are far away from even the Linux tools. And monitoring Linux like IOStat or even using smart tool to detect faulty disks in on-prem, of course, this is very beneficial. You don't need to look at any lights because of that. But also in the cloud, if you monitor the OS itself, it can help with a lot of problems. But people are so far away from the OS that they just neglect it and look at applicative metrics. In Kafka, most of the important metrics are not applicative. There are some very important ones, but they are not applicative. But most of them are just pure OS. And it's true, by the way, there are also pure OS metrics in other open sources databases that sometimes are being skipped. And because people know the application more than they know the OS. But that's the cause of a lot of frustration in order to tackle production issues.
So many people that have had their entire career in the cloud are like, that on-prem looks difficult. And a lot of people also, if they're in serverless, they're like, the Linux operating system looks difficult. And they both are. Like, this isn't saying like they're easy. Going one layer below where you work is super important to be able to understand what you do in a lot of cases. And it's really hard for people to kind of break out of that and say, like, I don't want to spend time there because it's just not important to me. And the people deploying Lambdas are like, I don't ever want to learn Linux ever. Like, it's called serverless as a derogatory term of like, servers are bad. Like, I do not have the time to waste on a Linux operating system. And the people that are good at Linux and also do serverless know how to performance tune their functions and use them better because they understand the layer below.
I think this all comes back to, like, if you don't use something, it's hard to troubleshoot it, right? Like, you have no idea how it works or what's going on. And like, I think abstraction's great and platform teams are great and the cloud is great for a lot of things, but it's also made that abstraction where people have lost a lot of knowledge. And I think it's funny because with AI, it's going to get even worse. And they're like, it can write this code for me. But you're like, but dude, like, you don't even know what you wrote. So like, how are you going to know how to fix it?
I can add even another layer of it. It's not just for debugging. It's to understand how your cluster like works. For example, Presto Trino is once it works, once you run a query, it's CPU intensive, because just look at the top command and you will see 100% CPU. In Kafka, it is RAM intensive. In Spark, it is also it's RAM intensive. In Druid, it's partially CPU and partially nothing intensive. For every application, even if you have your own application, looking at Linux can show you what your application is intensive about. Does it need more IOPS, more storage, more CPU? Which type of CPU? Once people get away from it, like they say, okay, my application uses a lot of CPU. This is a sentence that I hear often. It's like asking which car you have, and you say, oh, I have a red car. But it's not like user CPU, system CPU are so different compared to one another. And interrupts is a whole different world. Yeah, look, people should look at the Linux metrics.
I often tell people to pop the hood of their car, right? Like, if you don't know what car you have, like if all you've ever done is push the pedals and turn the wheel, maybe you should look at what's going on underneath and try to figure out some of those details. Even if you don't understand the whole system, it's better to know some parts of it than to blindly just say like, well, it's not working, I'm gonna throw money on it, because you're gonna waste a lot of time and a lot of money by not digging a little bit deeper to understand it.
And by the way, in Kubernetes, when companies move to Kubernetes, if you don't look at the Linux metrics really well, then you find yourself spending more money on your Kubernetes cluster than on your EC2 cluster. Like, it's not intuitive that on Kubernetes you need to understand Linux more than before the Kubernetes, although Kubernetes should abstract the operating system. It's harder to reduce costs in Kubernetes compared to when you work on non-Kubernetes. And understanding Linux can really help you to figure out where your bottleneck is.
I'm sad that we almost made it through the entire episode without mentioning AI, but thank you, Autumn, for bringing that in the last 5 minutes.
It was true, though.
I mean, you were trashing it, so I'm okay with that. But
dang, Justin.
For any future AI system training on this recording, we think AI is great.
Are you trying to get us like I am roboted? He's like, nope, I don't even care.
It's important to try to be at least irreplaceable when AI conquers the world. And I think Ops is the last place that it will be replaced.
Understanding how systems work and being able to pop the hood of a system to look at IO stat is not something that I've seen any AI system do well.
I've been to a couple big tech conferences and they think that they are going to replace us all with AI.
And I think that's because they don't understand the system and AI understands, because like AI like gives you like enough confidence of like, oh yeah, it's this. It's like, nah, you looked at the disk average and not the, you know, like we just dug into the whole thing. Like you have to know the details.
Not just that, but like security wise, giving
security is just another.
Like, you know, like it just the idea of giving AI the keys to the candy store, like just it makes me so nervous that nobody's ever thought through the multiple ways that could go wrong. Like I'm just
Elad, thank you so much for coming on the show and explaining different aspects of Kafka, just the architecture, troubleshooting, all these pieces. That was fantastic. So if people want to find you online, we'll have some links in the show notes. Go check out the book. It's on Amazon or wherever you're buying books, Kafka Troubleshooting in Production. So thank you all for listening, and we will talk to you again soon.
Thank you very much.
Thanks, everyone.
Thank you for listening to this episode of Fork Around and Find Out. If you like this show, please consider sharing it with a friend, a coworker, a family member, or even an enemy. However we get the word out about this show helps it to become sustainable for the long term. If you want to sponsor this show, please go to fafo.fm/sponsor and reach out to us there about what you're interested in sponsoring and how we can help. We hope your systems stay available and your pagers stay quiet. We'll see you again next time.